Hi there, welcome to this walkthrough of a fascinating project discovering topic categories in large text corpora using Gemini 1.5 Flash. Classifying text into topics is a common task in research and business, but what if the topics aren't predefined? This notebook demonstrates how to uncover topics in unstructured text data using titles of congressional bills as an example dataset. Traditional topic modeling methods like latent allocation often struggle with identifying all relevant topics or create irrelevant ones. They are also highly sensitive to text preprocessing. Large language models, especially the ones like Gemini 1.5 Flash with very long context lengths, may be quite useful for tasks like this. In this particular example, I use a dataset containing 20,000 titles of congressional bills, which is a subset of over 400,000 titles in the original dataset. These bill titles represent a range of policy domains from healthcare to taxation. I first load the libraries which are necessary to complete the task in this particular project, and I also load the API key here in the first code cell. Then I define a function, a helper function, which takes the raw input text as the input and generates a prompt with that input text. The input text here is the congressional bill titles. This function takes a CSV file containing bill titles as input and the column name, the name of the column which stores the bill titles in the CSV file, and returns a list of titles as prompt. I use the congressional bills dataset, as I said before. Here in this cell, I load the CSV file containing those congressional bill titles. As I said before, this is a random subset of the original dataset. Here I use a random subset with 20,000 titles in it. I am not able to use the full dataset, which contains more than 400,000 titles. If I use the full dataset, it would exceed the maximum token I could fit into a Gemini 1.5 Flash model, or even the Pro model, which has 2 million context length. I use Gemini 1.5 Flash mainly because of efficiency concerns. Gemini 1.5 Pro of course has better reasoning capabilities and even greater context length, but here I tried to minimize the cost, and I tried to get the output as quick as possible from the model. Because of that, I decided to go with the Gemini 1.5 Flash model instead of Gemini 1.5 Pro model. I'm using caching to make the experimentation more efficient. I am trying several different prompting strategies in the experiment. In all experiments, I use the same input text, this component is constant across different prompting strategies I use. So I'm using a caching strategy to minimize the cost and to make the text generation process more efficient. I am putting the list of wheel titles into a cache, and I'm using that cached content in different prompt scenarios. Here in the first prompt scenario, I go with a minimal instruction strategy. I just ask the model to develop a topic taxonomy of the titles. I don't give very specific instructions about the desired qualities of the identified topic taxonomy. I just ask it to develop a taxonomy without any specific instructions about the desired qualities. I just tell it that the topics must be mutually exclusive, which is a necessary condition for any good taxonomy. And I also give some instructions about the desired response format. And in this first scenario, Gemini 1.5 Flash came up with that response where it identified 10 different topics in the data. When we go through those categories and look at the examples the algorithm provides for each category, we can see that those are categories that really exist in the data. They are all relevant. The examples given for categories confirm that those categories really exist. These topics really exist in the data, and there we have a considerably large number of topics identified here. In the second prompt scenario, I go with more detailed instructions about the desired qualities of the topic scheme, and I specifically give some instructions about the kind of topic scheme I want. Here I tell it the identified topics must describe different policy domains, and I give a few examples like transportation, environment and defense, which could be identified by someone with even basic background on public policy, even before looking at the data. And I give those three starting examples and ask the algorithm, the Gemini 1.5 Flash model, to basically extend that list and come up with a more comprehensive list of topics using the data. And here in this scenario, it identified 12 topics, and again, when we compare the identified topics to examples under them, they all look relevant categories, and the examples provided under each topic scheme are consistent with the description of the topic category the algorithm provides. Uh, and in the third scenario, I asked Gemini 1.5 Flash to come up with as many relevant topics as possible. And here we can see the output, and this nudging strategy had an effect on the number of topics it was able to identify, but not a large effect. In this case, it identified 13 topics, which is greater than the number of topics in the first scenario and the second scenario, but not a big difference. I used that strategy because I suspected it might be trying to minimize the number of topics to keep output token length as small as possible. And it seems like there is such tendency, but it is not a big effect on the output. Alright, that was a quick walkthrough of my project, which offers an alternative to topic modeling methods. In this case, in this example, Gemini 1.5 Flash came up with really relevant topic categories, but this may not offer a full automation of topic discovery process. The categories identified by the Gemini algorithm sound really relevant given the examples it provided, but someone who uses those algorithms for that kind of purpose needs to like use the output from Gemini as a starting point. It can help as a great productivity boost, but it may not offer a fully automated solution to that specific problem. But it can help researchers or data scientists to speed up the process incredibly. Thank you.